Okay, so now we are going to see this question. This question came in GATE 2012 for 1 mark. It is a pretty standard question where we are given a particular mathematical statement, a particular statement is given and we have to convert that into a particular mathematical logic. Okay, so they are saying that some real numbers are rational. And then there's writing this predicate real and rational, something like that. So you can understand that real x means a particular number is real, rational x means a particular number is rational. In that fashion, we have to see that which of these four options are correct translation for this statement into mathematical logic. So they're saying that some real numbers are rational. So we know the of for all there exists quantifiers. So how we can reduce this into some mathematical logic statement. So if somebody is saying you that some real numbers are rational, then how you are going to express that in such notations? Some real numbers are rational, it means there exists some number which is real and rational, right? So this is the way of saying that, right? So there exists some number n, and that number n is real also, and that number n is rational also. That is exactly what if some real numbers are rational, then definitely there exists at least one number which is real and rational. Okay, so we are going to say something like there exists x, okay, where it is real, it means real x is true, and it is rational also. So rational x is also true. So there exists some x where it is real and it is rational also. So we can clearly see that C is that option where it matches our statement. So there exists x, real x and rational x. So C is the answer. Okay, just I'll give you one another way in which you can think of it. Okay, so let's take the negative of this statement, something like this, that okay, if some real numbers are rational, let's say this statement is not true. If I frame that statement and take the not of that, then that is the truth, that is the true statement which we are talking about. So if somebody is saying that some real numbers are rational is not true, then how they are going to say? They are going to say that real numbers all real numbers are not rational, isn't it? All real numbers are not rational. And if all real numbers are not rational, then this statement is false. So basically these two statements are inverse of each other. So if we take not of this, then that is same as this. So if all real numbers are not rational and this statement is false, it means we take not of this, it means that there exists definitely some real numbers which are rational. Okay, so my point is that if we try to move in this format, then we again should get the same answer. Let's try it whether it happens or not. So this internal thing I have to write it in terms of all this. So all real numbers are not rational. It means for all x, okay, if that particular number is real, then we know that it is not rational. So if it is real, it implies that it is not rational. Okay. So this is the way in which we can express it. Now you know that if we apply not outside and then we try to introduce this not in the expression statement itself, then there are ways. You might be knowing that for all changes to there exist, and then the not applies to this thing. Now this is what? So you know that A implies B, okay, can be written as something like not A or B. Okay, so in the same fashion, the not will be applied to this internal thing, and this A imply this will be converted in this format. So I can say that real x A implies B means not A or B. So I can say that not real or, okay, not A, or B. And B is what? B is simply not rational. X. So here also it will be X, obviously. So this is the statement which we have to take the not of it, and then from De Morgan's rule we can definitely say it something like, so if A or B is there, and if A or B is there and we are taking not of that, then what we do, we take not of A and not of B, right? So similarly here we are going to take not of this entire thing, which will again become not, it will become again simply real X, and it will become not and not, again it will be cancelled, and it will be simply rational X. Okay, so you can see that the same statement we got again, that there exists X, real X and rational X. It is just for an explanation that you can start with any logic which comes to your mind, and then if you properly handle all the rules of the mathematical logic, then you will get the correct answer in any way. Okay, so the correct answer is C, as we discussed earlier.